Hello everyone, this is Kyle Welch with RCR Wireless News. I want to thank everyone for attending today's webinar, End-to-End Indoor DAS Small Cell Measurements and Analytics, Streamlining Small Cell Measurements, presented by Anite. Our presenter today is Deepak Sivakumar, Manager, Sales Engineering at Anite. Deepak, he currently works in supporting customer implementation of network analytics, solutions for drive test, OSS, call trace, small cell DAS, and network management. Deepak has over 6 years experience across multiple business disciplines, including sales engineering, project management, network deployments, and customer service. He also holds a Master of Science in Information and Communication Sciences from Ball State University. Also, helping out Deepak on the Q&A section of the webinar is Alex Chua. Alex is the Director of Product Management and Business Development at Anite Network Testing. He is responsible for the America's regional product requirements and manages the local Nemo R&D and sales engineering teams. Alex has over 15 years of experience in the wireless industry across multiple business disciplines, including product management, business development, product marketing, and field applications. Alex also holds a Master of Science in Electrical Engineering and Communication from the University of Illinois, Urbana-Champaign. At this time, I'd like to pass the presentation over to Deepak.
Okay, thanks a lot, Kyle. Thanks everyone for joining the presentation. I'm Deepak Sivakumar. I'm with Sales Engineering at Anite Network Testing. And today's topic of discussion is mainly the end-to-end solution to really optimize and analyze instruments in a DAS or a small cell system. So it's mainly how do we cover and streamline systems, especially in an indoor in the indoor space. And as part of the agenda for today, I'll start off with a small overview about our company, and then we can drill down into some of the challenges and requirements in indoor testing, followed by an actual customer case study that we have implemented for one of our customers. And finally, we'll wrap up with our summary and then open it up for any questions as well. Again, thanks a lot for joining, everyone. To start off, our company is Anite Network Testing, and we are a specialist in wireless testing with about 500 folks globally. And recently, we've been acquired by Keysight Technologies, so we are now part of the Keysight family. But our focus, again, is still mainly on providing tools to optimize wireless networks. So within Anite, we have two divisions. One is the network testing, and then there is the device testing as well. I come from the network testing side. So mainly our customers, we have a wide area of customers in the mobile ecosystem. So mainly operators, equipment manufacturers, we have services companies, and also we do have some chipset vendors and regulators as well. We have offices globally in Oulu, Paris, Singapore, Dallas, Forest, and Chantilly, Virginia as well. So again, the products that we provide is mainly used for advanced wireless network testing and analytics. So we don't do any services or testing ourselves, but we do provide the products that all the customers that I mentioned earlier utilize to either deploy or fix issues in a wireless network. And there are a lot of different use cases and phases within an indoor life cycle where we can come in and plug in right away. Some of them have been noted down here, such as the site survey phase. There is the troubleshooting, the acceptance and benchmarking phase, site optimization, and finally the reporting and the deliverable phase that a lot of you already are involved with. So to start off, let's talk about what are the challenges and requirements when it comes to the data collection phase. And to just start off, just to go over what data collection is, this is the first step in the optimization or the site survey process. So this is where you actually have a walk tester who walks the venue, collects data from the venue, and utilizes that to analyze post-process. So this is the first step in the process, which is critical. And some of the challenges that we have seen mainly when it comes to data collection, is it is extremely time consuming. You're working with multiple venues, you're working with multiple floors within these venues, and it's very hard to actually walk across all these floors, and it is a time-consuming process. And moreover, you also have limited access to a lot of these facilities, especially if you're working in the government space, or if it's a secure building. You might either have to be escorted to collect data, or you might have to come back at a later time. So it is a time-consuming process, and the data itself is scattered. So you have scattered measurement data, which means that across all of these floors, you have so much data that you're collecting, which you would have to somehow organize at some point of time. So there is the challenge of having a lot of this data collected as well. And then you have limited or no GPS. So unlike macro, where you have GPS fix, for indoor you don't. Most of the times you don't have a GPS signal. So that is something that is a challenge as well. And then to add on, there are a lot of tools out there, a lot of tools and processes out there, which makes the walk testers entire process a lot harder, especially if you have tools out there that are not simple enough to utilize from the get-go. It makes it a lot harder for the entire indoor cycle to go through. And you also have processes that are defined by your customers, or even at times you have processes defined by operators which are simple, and at times it is complex. So the real question is, how do you utilize a solution that can simplify, even if you do have a complex process that you're working with? And finally, all of these, at the end of the day, all of this results to a delayed venue acceptance. So this is where instead of having results right away when you're in the venue, you usually end up having to come back later on, which increases truck rolls. That significantly increases your labor costs as well. So these are the challenges to start with, and some of the requirements at this point that can address some of these challenges are that the solution that you utilize has to be a lightweight solution with a very good battery life. It has to support the simultaneous use of multiple devices, especially if you are involved with any benchmarking walks in neutral host venues. At that point, you need to have a solution that you can utilize for collection for multiple devices with multiple SIM cards. And then there has to be a seamless connectivity between the controller and the agent units. This is where you have a controller unit controlling all the UE terminals and the scanner. And there has to be multiple testing scenarios as well that is fully supported. So depending on the venue, it might be a legacy 3G with LTE, or there might be Volte already deployed in some of these venues. So the solution really has to address a use case where there are multiple testing scenarios that is mandated by the operator. And finally, you also have the application testing with scripts, which means that besides testing just RF metrics, it is also important to go to the application level and test actually application level KPIs such as Facebook, Twitter, Instagram, LinkedIn, whatever the end user is currently utilizing. So this is where you can really understand what is the customer's perception of the network. So this is something that operators have started testing as well. And finally, all of these log files that you collect has to be, the collection tool has to have that capability to upload them directly to an FTP location or to a post-processing platform that would pick up all of this data and process it for you. So let's look at some of the challenges with post-processing now. And post-processing is the second step in the process where, once all the data is collected, you have that information, and it is now time to actually analyze and actually view all of these KPIs on a map or in a report, especially when you're working with vendors or operators. You might have some kind of end deliverables as well. So this is the phase where you really look at the data and analyze for any one of the use cases such as site survey, benchmarking, acceptance, or even troubleshooting. And the challenges mainly are, data loading is a big challenge. So especially where you have multiple floors, unlike macro, it might be just one cluster. It might be a couple of clusters and you can load it together. But for in building, you have multiple floors, multiple zones. And the problem, what is seen in the industry right now is there isn't any seamless way to load all of this data together so that the engineer doesn't have to repeatedly load floor by floor. And that's a big challenge. And then the same goes for venue and flow management. We spoke about scattered measurement data a few minutes ago. And how do you manage all of this? How do you manage and organize all this scattered measurement data? And that is another aspect that needs to be improved in post-processing. Finally, you have your reporting and analysis. Reporting is something a lot of the services companies especially are working with. So if you're a services company, you know how labor intensive it is, where you are either copy pasting all of these plots, or you're in some way or another, you're manually doing a lot of these reporting. Instead, there has to be a way to seamlessly achieve automated reporting so that your technicians or your engineers' time is saved. And then you have analysis and troubleshooting as well, which is being done manually. And to just summarize this slide, with multiple floors, the use case is different right now. The scenario is different. There has to be a way within post-processing to address all of them in a very easy way instead of doing it manually. And the requirements now, they align with the challenges we just spoke about. So mainly, it has to be automated. The post-processing requirements, it has to be automated completely, where data is centralized and processed automatically. So what this allows you to do is manage all your in-building rollouts for your entire nation together. And also from a data upload standpoint, you should be able to upload all the data straight from the venue to the post-processing platform. So this is key because especially in situations where you have a technician out there in the field, instead of having them come back with all the measurement data, the better way is to actually have them upload all the data straight to a post-processing platform, which post-processes the data and gives the technician some kind of intelligence as to what is happening within the DAS venue. And the same applies for automated reporting and dashboards as well. There has to be an easy way to report and show you some dashboard summaries. The post-processing platform should also have support for flow plans, DAS transmitter informations, which is your reference overlays. So this would be all your transmitter information. And finally, it should definitely have support for the IB wave design files as well. So in one way or another, like right now, IB wave is a standard for design. So the output, which is the IBWC file, has to be compatible with the post-processing platform as well. And finally, the post-processing platform also should have a full support for all the collection tools, at least all the major collection tools used for in building, because a lot of the times our customers have already purchased an existing solution, and it doesn't make sense to actually replace it with something else. So the post-processing platform should really support all the major collection tools. And I've just described some of the tools out here that you can look at, and we can definitely answer any other questions in case you had about collection platforms. So to just go over some of the popular indoor KPIs that are being measured right now by customers and being pretty much used out there in the market, there are three different blocks that you see here. To start off, mainly an antenna health test. So this is where you actually have a walk tester out in the field, and they are at the venue, and they are doing a check for basic RF coverage. So this is where they understand what is the RSRP, RSRQ, mainly coverage parameters. Also, it's important to understand are the antennas placed in the right location? So there's a placement verification. Are the antennas transmitting the right channel, ARFCNs? Is it also transmitting the right PCI, PSC, and the scrambling codes? So this would be more of an antenna health test that is done on the venue itself. And then besides that, you also have your flow testing. And you can see that these are KPIs that you can see either through your post-processing platform or on the venue itself. So accessibility is where you check to see if you can access the network. So all your your connection setup, all of these RRC connection setup is measured here. Retainability, that is, can you keep the service when you walk in the network? So that is where you have retainability. You also measure your drop calls under retainability. Mobility is when you check to see if you can move around the network. So all your handovers are measured here. Integrity is where you check to see your throughputs, your jitter, packet loss, delay. Macro ingress is mainly when you try to understand what is the macro penetration coming inside your building. So how is your macro impacting your DAS deployment? And finally, quality of experience is where you start measuring your application level KPIs. So your Facebook, Twitter, any of the customer, any of the customer applications that is being used out there. Entrance and exit testing, the other block that you see is mainly when you walk in and outside a venue. So this is to mainly analyze what is the relationship between your macro and your DAS. So a couple of things you can do is, handover testing, which is in your connected mode. You can test your handovers, and then you have your cell reselection, which you can test in your idle mode as well. So what is the solution that can address all of these challenges and also satisfy these requirements in your network? So from our standpoint, from our perspective, we have helped multiple customers with this, and we wanted to sort of go over this with you in terms of what can be used to streamline this entire measurement process end to end. So from a collection standpoint, the solution is Nemo Walker Air. And Nemo Walker Air is mainly used for walk testing. And as you can tell, it is a backpack solution, which is extremely lightweight. So the solution, it has to be lightweight to make the walk testers' job a lot easier, especially because they're scaling multiple floors. And it has to be discrete from a standpoint that, especially when you're walking, venues, when you're walking, a government building or a secure location, you shouldn't be gathering attention to the backpack. In this case, it looks like a college backpack, once you zip it up. And all the walk tester would be carrying with him or her at this point is a tablet, which is the controller unit along with the backpack solution. And all of these terminals in here that you see, all the 6 UE terminals, seamlessly connect over Bluetooth with the tablet. So you have a controller agent configuration set up in this case, and it's very important to have this seamless UE connectivity. And on top of that, you can also add a scanner to the mix where if you wanted to scan and collect any receiver measurements, at this point you can add your DRT or your PCTEL scanner to this existing, which makes it, and all of this is connected seamlessly, and it just makes collection a lot more easier. And device synchronization between all of these are key because you can imagine all the walk tester looks at this point is the tablet. So the walk tester has to have a real-time update of all of these UEs and the scanner on the tablet so they can see and analyze a lot of the validation use cases. So when they're walking a venue and trying to analyze an antenna, at this point the walk tester is pinpointing on the map, is dropping markers on the map, and at the same point they can see if the antenna is transmitting or not on the map real time. So so this is what the real time does. So real time alerts are provided by this solution, by this tablet backpack solution, And the walk tester can understand real time if an antenna is transmitting or not. Is it a faulty antenna, or even if the antenna is missing? So there are a lot of different alerts that can be generated, and mainly the purpose of this is to identify these issues when you're on the field, so that you don't have to roll truck, or you don't have to come back to the venue, or you don't have to be flying your engineers back and forth over and over again. And mainly with IBWave, with the design platform, we are completely integrated with the IBWave mobile planner and with IBWC design files. So you can, once you import your IBWC file and collect all of this, you can output this file back into IBWave to actually see what was your planned coverage versus your actual coverage in the venue. So that kind of analysis can be done, and this can be done over post-processing as well, but this is seamless in terms of doing it with the design side. And finally, once all this data is collected, you can upload this data straight from the device to the office or to your post-processing platform. Finally, in terms of technologies, we cover all major technologies: LTE, Volte, carrier ag, 3G, and Wi-Fi as well. So in terms of post-processing, the solution, the end-to-end solution is Nemo Synergy. And to just go over Nemo Synergy quickly, it is an enterprise web-based platform where you can bring walk test, OSS data, multiple data sources into one platform. In terms of today's webinar, we're mainly talking about walk test data. So the walk test can be completely automated. The processing can be completely automated. So there is workflow automation in terms of the data that has been collected. So there is no manual processing by your engineers. Instead, the data can be received by Synergy, and intelligently we can assign different floors to different buckets that we can use to actually post-process and actually make sense flow 1 from flow 2. We can provide consistent deliverables. So if you have deliverables back to your end customers, we can provide consistent deliverables that always align. There are dashboards that are provided as well, which they're automated, so our customers can really understand what all the summary KPIs look like. And then mainly all the acceptance can be done when you're at the venue. So before your field tester even leaves the venue, you can get a quick report back to the field tester, which just shows them areas where the DAS is a pass, where the DAS is having issues, and also if the venue is a pass or a fail, all based on the KPIs and thresholds that you define. And the scope of Synergy really goes beyond walk test. At any point of time, if you decide to bring in OSS data, so this is data from your switches. So mainly if you have mainly for an operation, from an operational standpoint, if you wanted to manage the daily operations of a DAS network, if you wanted to manage the health of your DAS, you can always bring in OSS feeds and tie it with your walk test data, or just monitor OSS by itself. So really you can complement walk test with your OSS feeds as well. And finally, our collection platform, our post-processing platform supports a wide set of collection tools. And also from a design standpoint, we support IBWave as well. And we'll be happy to share with you if you have any questions regarding what are the collection tools that we support today. And one of the customer case studies, a very successful case study that we have achieved here, is with an operator who really had a need to deploy multiple in-building venues, multiple in-building systems all across the nation for multiple markets. And really the objective was to improve or complement their existing macro network with an in-building network as well. And there were different phases that they required assistance with, mainly their site survey, all the way to their acceptance, benchmarking for existing venues. And finally, the objective also was to move from a RF approach to more of a customer-centric approach, looking at mainly customer experience KPIs as well. And the solution that we deployed was the Walker Air for walk testing and Synergy for post-processing. And finally, I mean, the benefits once we deployed this was multiple. There were multiple venues that were turned on air simultaneously after acceptance. There were huge reduction in the labor costs because of decreased truck rolls. And overall, in venues that had benchmarking done across multiple carriers, the operator was able to identify exactly areas where they had to fix or resolve issues. So there was an overall RF improvement as well in building venues. And finally, for some of the venues where they went on air, where they did not have an existing DAS system earlier, there was immediate revenue that was recognized, where because of the increased usage inside a lot of these venues. And some of the features within our platform that really addressed or helped this customer are, one of them is mainly the real-time DAS verification. So this is the case where, you have your walk tester walking the venue, and they are walking across the path. Like for instance, you can see all those green antennas, and then there is a red antenna in between. So they're walking the path, and they're walking beside each antenna and checking the coverage, the PCI, the channel information, and they can really tell if the antenna is transmitting or not, or even if it is transmitting, they can tell if it is transmitting the right channels or the PCI. And if it does not for some reason, we can flag it as a red antenna, which in this case, there was a missing antenna. There was no antenna, and we just flag it as a missing antenna. So real-time DAS validation can be done when your folks are on the field, so that you don't have to repeat. You don't have to really take this information back to your office. Instead, you can do on the site spot validation. And also, another useful thing here is when you're walking, you can also, when you're walk testing, you can also check if there's any handover with your outdoor macro site, because at any point of time, if you were to hand off and connect to your macro site, at that point, that is something you can flag right away that you need to address, because at the end of the day, we need to make sure that macro interference is kept in these venues. So this is mainly for venue acceptance. So you have your field testers actually go out and collect data and bring it back to your office, and there are so many challenges that at that point you run into. You might have to come back at a later on period of time to actually fix issues, or we've seen the optimization phase just bleed and go over a couple of days, months. So instead, what you can do is with Synergy solution tied with the Nemo Walker Air, as soon as you collect all the data, you can upload it straight to the Synergy solution, and we can provide automated reports that show you if your venue is a pass or a fail. So you can define, based on certain thresholds, and every operator is different. So you can define some thresholds. Your RSRP has to be greater than neg 95. You can define your thresholds, which really flag, at the end of the day, we can show you red light, green light if your venue is a pass or a fail, which really tells the field tester and even your engineers who are in the back office if those issues need to be fixed right away, or if it could be addressed at a later on point. And also from just a coverage standpoint, if you notice the map that I'm showing you, right above sector 1, there are areas. There is a small area where there is you don't see any coverage, you don't see any bins there, you don't see any data points there. So you can always do a quick check of your walk route as well to see if your field tester had covered your entire venue or not. So in case you've missed any locations, instead of coming back 1 week later, you can always do a quick check to see if all your area was covered. And if not, you can collect it right away and rerun a report to see if it was covered or not. And to just tie the previous slide, the venue, the venue acceptance. In order to complement the venue acceptance, we also have dashboards that can complement it. So from a nationwide standpoint, you can have these dashboards where you would just come in and just like how you would log into your Gmail or any other web application, you could log in and check how all your venues are performing. So this dashboard can tell you exactly how all your venues are performing and where all the issues are. So for instance, if you look at retainability, I have 95% retainability with around 119 success and 7 failures. So I can so if say if a senior director or a manager is looking at this, they can click on failures and drill down directly into the exact issues that actually cost these 7 failures. So really, you can create a relationship between your higher level management all the way to your technicians, because at this point, even the technician would be interested in knowing what is the manager looking at, and was the venue really at rest or not. So besides showing you an overall standpoint, overall venue dashboard, we can also drill down into certain KPIs that an engineer might be looking for. So your data throughputs, your coverage parameters, all of that can be exposed as well. So at the end of the day, you really have a good overview about your entire venue. And we can have multiple venues, different markets combined. And you can use these dashboards as well to provide to your end customer. So if you're a services company, instead of providing the usual Excel or your PowerPoint reports, you can also, as value added, you can always provide these dashboards back to your customer where they can log in and actually check and see how their venue is performing. The next one is an antenna health check. So there are a couple of ways to achieve this. We already covered how to do it using the collection, which was the real-time validation, where you walk the venue, your walk testers at the venue and can identify all the issues when they are at the venue. That is one way to do it. The other option is to actually do it through post-processing. So this is where you have all the data that is collected, and you take all this data back to your, you upload it straight to Synergy. And once it's uploaded to Synergy, at this point, we can generate a report such as this that tells you exactly what is the health of all your antennas within your venue. So if you have, in a big venue where, if it's a huge stadium where you have multiple zones, multiple antennas, at this point, we can exactly tell you which one of these antennas are transmitting. And even if they are transmitting, what are the signal levels and also the power levels of these antennas, which gives you an overall snapshot of your entire network. It gives you a snapshot of all your antennas as well. And, again, we have made it dynamic in a way that you can actually go in and change some of the thresholds. So you can change your power thresholds, your RSCP, your RSRP thresholds, and we can actually show you the antenna that is transmitting, the channels that it is transmitting. So in this case, it's transmitting on channel 4359 with a PSC of 384, and it tells me my RSCP is neg 48.2 dBm. So this can be done across your entire venue, and all of this is completely automated. So there is no manual reporting that has to be done by your user. Instead, they can upload this straight to Synergy, and you have this report that is pushed back to your engineers. The RAT summary is another report that we generate through Synergy. So this report is mainly to understand what is your random access channel performance in your network, mainly to analyze your quality of service and capacity. So this is where if you have a couple thousand users trying to access the network, you want to make sure that there is no congestion-related issues. So we'll show you a couple of information such as the number of preambles, what is the last transmit power, and if it's LTE RAT, at this point we can show you all the messages. So message 1, 2, 3, and 4, where you start looking at your your message 1, your preamble sequence, you have your random access response, and based on that, also we can show you, your UE identification info, and if there is any other information that is relevant to RAT as well. And we can show this also based on the entire venue, and also we can drill down into each floor and on a carrier level as well. By carrier, I mean by the channel level. Another report that is very useful to actually capture and identify issues on your DAS network is the indoor call failure report. So this can tell you exactly the locations where you have issues on your DAS network, or your DAS or your small cell network. So as soon as you collect your data and you push this data to the Synergy server, the Synergy immediately runs a report that tells you exactly the areas where you have issues. So your drop calls, your access failures, your handover failures, your block calls, all of this can be reported back to you, along with the root cause on why it happened. So we can show you a before and after snapshot of what the KPIs look like, but we can also tell you why that issue had occurred. And the one other thing we can also tell you is, did the issue occur on a macro or a DAS network? So you can identify exactly areas where the calls dropped on your macro versus where the calls dropped on your DAS. Over-the-top applications is where traditionally users, operators, vendors, the testing that is done is mainly for RF level KPIs. But now what we've started seeing is, operators have started looking at application level KPIs as well, where they're really trying to measure the end user's experience. So this would be where you can measure your YouTube or your Dropbox, Instagram, Facebook, or LinkedIn to really understand what is the user's perception of the network, especially because in a live network you'll find users doing at least one of these tasks, one of these applications. So for example, like Facebook, we can actually report back to you once you test it. We can tell you what is the success rate of your wall feed loading, and how successfully is your friends list loading, and also we can tell you if there's any delay in you posting a photo back on Facebook. And the same applies for LinkedIn and Instagram as well. And for YouTube, and I've mentioned YouTube here, but this could be any streaming application. So in this case, we can show you what is the MOS quality. So based on YouTube streaming, we can tell you what is the MOS that is reported, and also how long is there any buffering time, is there any buffering delay in loading your video. So those kind of KPIs can be measured, and we can report it, which really shows you the true quality of experience in a network. Finally, we have the macro ingress KPI. And this is my last slide in terms of features, but then this is one of the most important KPIs that is being measured, and you can measure it in two different ways. One is on the post-processing side, and you could also catch it on the data collection side. So on the post-processing, once all the data is collected, you can run a report, and we can show you on the UI areas where you have macro penetration inside your venue. So you can see the map here where you see a lot of green, but there are also locations where there's some red, which means that macro is actually serving those locations in your venue. So this is where these are locations that you might want to immediately look after and analyze and optimize, especially because this is in turn going to impact your throughputs and capacity. So one way is to run it through post-processing, and the other way is to actually analyze it when you're on the field, real time. So the other block that you see for analysis of RF ingress is where we can actually show you real time on the collection if your macro or your DAS is serving that specific location. So that really helps in understanding what is the macro penetration, because at the end of the day, our objective here is to have complete, or improve your DAS dominance and reduce the amount of macro interference coming inside your venue. Okay, so in summary, the solution that we have gone over today, Nemo Walker Air with Nemo Synergy, is really an end-to-end solution that addresses a lot of the issues and challenges and requirements when it comes to drive testing, walk testing, and post-processing, mainly from a standpoint that instead of using multiple tools which don't sync with each other, we have two platforms here that are completely in sync with each other. And the way Anite has positioned ourselves is as an end-to-end solution company, which really addresses and works as a partner with you in all phases of an indoor life cycle. So, it could be the network optimization, or it could be a network benchmarking phase, or even a network monitoring phase. But this should definitely address a lot of the challenges and requirements when it comes to in-building testing. All right. Thank you, Kyle. Up to you.
All right, great. Thank you, Deepak. We've had a lot of questions come in. We'll get to as many as you can. And if anyone has any questions at all, please let us know. Or submit them via the control panel. So the first question we had really kind of relates pretty well to the last slide you were on before the summary. So what are the top 3 KPIs that you see operators looking for?
Okay. So the top 3 KPIs operators have been always looking at is, when it comes, coverage is a very important KPI. It's very important to have excellent coverage. So if it's an LTE network, they would expect anything greater than NEC 92 to NEC 95 dBm in these venues. If it is RSRQ, above NEC 112 dB in these venues. And when it comes to a capacity standpoint, throughputs are also measured. Throughput is a very important KPI that is measured as well. Both downlink and uplink throughputs. And finally, I would say even the macro ingress. I think that was the last slide that I had. Macro ingress is also a very important KPI that we can actually calculate based on certain RF conditions.
Okay, great. Next question we had in. How can you check antenna details using the collection tool in the field?
So this is Alex. The Nemo Walker Air has the capability to detect antennas that are failing or not configured correctly in real time. Given that the database of the site information is available on the device, and in our case, we've been working with IBWave, using the IBWave file, the cell site information in there to make determination on whether the antenna at that specific location is good.
Yeah, and just to add to that same point that Alex mentioned, that is done. What Alex described was on the collection phase, and if if for any reason that you would like to test it on the post-processing side, we can still run something called the antenna health check report that gives you a snapshot of all your antennas and how they're performing as well.
Okay, great. Thank you, Alex and Deepak. So the next question we got in: how many UEs plus an RF scanner can be used at once with the Nemo Walker?
So the Nemo Walker Air supports 1 control tablet and 7 UEs together with a scanner.
Okay, great. Next question we had: what data formats does the post-processing tool support?
Okay, so we have a huge list, almost all major collection platforms when it comes to in-building. So the Nemo Walker Air, the Nemo platform is supported. There is ASCOM TEMS, JDSU is supported, Swisscall is supported, Verizon's Data Pro, AccuAir, AccuAir's platform is also supported. And we'd be happy to share more more collection formats. But on the scanner side, the PCTEL DRT is also supported on the scanner side.
All right. The next question we had in is also about the Nemo Walker. Is there an external battery pack to power both the UEs and the RF scanner?
I'm sorry, can you repeat the question?
Yeah, absolutely. In regards to the Nemo Walker, is there an external battery pack to power both the UEs and the RF scanner?
there is there are external battery packs here that's located within the backpack.
Okay, great. Next question we had is really around analytics. So, does the analytics platform support OSS data? Also, what other data can analyze and be imported, and what is the benefit of doing something like this?
Sure. So yes, absolutely. So OSS data, so that is within the scope of Synergy, where besides walk test or drive test, you can always bring in OSS parameters. So this is where you can bring in more information from your core at this point, especially your performance management, fault management data, your configuration management data. And the real benefit here is, for example, if you were doing a walk test and if you were to see a drop in a specific location, at the same time, you can trace this back to your network and see if the core, if the same drop was it because of was it because of an E node B drop, or so you can trace it back to your core to understand what was the performance of that specific cell site, and also you can correlate that information with your alarms, and also so you can look at the same time you can look and see if whether any alarms that were flagged during this particular time. And also you can take it one step further and see if there was any configuration changes that were made which actually triggered the specific drop. So really, end to end in terms of identifying even did the call drop happen because of a UE, or was it because of a network related issue?
All right, thank you, Deepak. Lots of questions coming in. We'll power through them. Again, if anyone has any other questions, please submit them via the control panel. And if we don't get to them on this webinar, they will be shared with Deepak and Alex. So the next question, can your tool analyze macro interference as well?
Yes, absolutely. So macro interference, that is the big issue in venues, especially stadiums where you have multiple cell sites surrounding the surrounding the stadium. So there are two ways to do it. One is through collection, where we can actually real time we can tell what is the macro sites that are serving the venue. So it is a real time spot test that you can do to understand what is the macro ingress coming inside the venue. The other way is to just do the other way is to just collect all this data, and once you upload it to Synergy, we can show you, especially on a map, areas that are served by DAS versus areas that are served by the macros, which helps you understand what is the current ingress inside the venue.
Okay, and I think the next question we got in really kind of flows well from the past one. So you talked about stadiums and large venue installments. What are some optimal LTE coverage levels in a DAS venue?
So for LTE, for LTE, I mean, it depends operator by operator what they would like to see. But as what we have seen so far, LTE RSRP has to be between, has to be greater than neg 92 and neg 95 to start with, and that should cover almost 99% of the coverage area. The same goes for RSRQ as well. It has to be greater than or equal to around neg 12 dB for 99% of the coverage area. And for LTE, besides coverage, it's also important to understand that the in-building signal level should be at least 5 to 7 dB greater than the macro signal, so that you have good signal levels within the building.
All right, a few more questions we have here. If one were to collect their own data with their own scanner, does Anite offer post-processing for pre-collected data alone?
It depends on what collection platform it is. Currently, we do support DRT. There is PCTEL as well. We also support the Nemo FSR scanner, which is our in-house scanner. If it is something besides this, definitely talk to us, and we can definitely discuss more.
All right, thank you. Next question: What are the Nemo Handy capabilities to test carrier Wi-Fi networks? Maybe Alex, that one's maybe better for you.
Oh, sorry, was on mute. Yeah, so I want to say with our latest version of Nemo products, we've introduced the support for voice over Wi-Fi in addition to Volte, and it's part of the official IMS standard, so we are able to test Wi-Fi with our tools as well.
All right, thanks. We had a question come in. So if someone was using a PCTEL scanner with the Nemo Walker Air, can you go into how this connection work? Would you have to have a PC connected to the Nemo Outdoor, or is there some sort of embedded software?
So on the PCTEL, we are actually connecting to it over Bluetooth. Currently, today, the model that we support with the Nemo Walker Air is the IB Flex from PCTEL. And what would happen is it would connect the scanner would connect to one of the UEs as part of the kit.
Wow, Bluetooth. That's great. So the next question we had in, does the end-to-end solution support Volte testing? Also, what Volte metrics would it show if it can?
Yes, yes. So the end-to-end solution that we went over, Nemo Walker Air with Nemo Synergy, supports complete Volte testing in a network, both on the macro and also on the DAS side. On the Volte side, this is mainly all the signaling, everything that's happening between the UE and the IMS. So all your, your signaling, especially your 200 OK, your invite STP, your 180 ringing, all of that information is captured, and we can show you Volte metrics, such as your Polka scoring, your MOS scoring, and just KPIs related to Volte can be shown for this.
Okay. Next
and
question.
Also,
sorry.
Just one other point. Besides the ones I mentioned, we can always, based on the voice codec in these venues, we can also tell you if it's a wideband, an AMR wideband, is it a super wideband, or if it's an H.264 video. All of this can be shown in our reporting as well.
Okay, thanks, Deepak. Next question we had, in what is the weight of the backpack solution, and which scanners are supported?
So the overall, let's just make an assumption that it's fully loaded. So say 6-7 UEs plus a scanner. So the backpack excluding the tablet, because the tablet will be in the user's hands. It will come in weighing around somewhere in the 13-14 pounds range.
Great. And what other scanners does it support?
Oh, I'm sorry. Scanners. We support 2 scanners today. It is the DRT4311B scanner, as well as the PCTEL IB Flex. And similar to the question that we had earlier with the PCTEL connection, the DRT is also connected to our kits over Bluetooth. So it's kind of a seamless connection.
Okay, good stuff. Looks like we have time for just a couple more questions here. So the next one, do you have ready-made dashboards and reports available?
Yes, yes. So we do have, as part of the analytics, so your question was dashboards and reports, right?
Yes, that is correct.
Yes, so we do have both dashboards and reporting that is available. So for customers who who have projects that are immediate, we have off-the-shelf dashboards and reports that you can utilize from day one. So you can tell if it's a benchmarking scenario. At this point, you might be comparing multiple operators. So the dashboard there would be completely different from an acceptance dashboard or a site survey dashboard. So based on the customer's use case and which phase of the indoor life cycle they are currently in, we have some off-the-shelf dashboards and reports that they can utilize.
Okay. Next question. Does the tool offer any capability for ad hoc protocol examination such as SIP and Volte?
Yeah, so on the collection side, as the user is going through the process of a walk test, we are actually decoding all the layer 3 messages as well as SIP messages in real time. So a user will be able to click on one of the SIP messages and read the decoded message. So it's really helpful when you're trying to confirm whether the 180 ringing or 200 OK actually went through while the test happened. And our tool is able to has the capability to decode that in real time on the user interface.
Okay. We had a follow-up question as to the Volte codecs we just asked before. So in regards to the Volte codecs, does the tool indicate the actual mode used for the call, such as actual kilobytes per second used by the RTP?
So if I understand the question, I'm sorry, go ahead. Yeah.
Yeah, so I think on the post-processing side, it does report the codec that is used, and same for the data collection in the Walker Air. We report the specific AMR codec that is used, so whether it's running at 13.85, 23.85 kilobits per second, that is visible to the user.
And Deepak, do you have anything to add to that?
Oh no, it's the same thing what Alex mentioned. We can report, based on what we see. If it's AMR, wideband, super wideband, and all of the FPS, all the frames per second, all of that information is captured as well.
Okay. Looks like we have time really for just one more question. So, what are the reporting formats generated by post-processing?
So the most popular format right now is Excel, we've seen, but there is also an option to generate PowerPoint plots as well. So there are two ways to do it. You can either generate Excel reports, or the system, or the Synergy system can automatically generate PowerPoint plots for you. So once you set up all your thresholds, all your colors based on the different markets you're working with, based on what the customer is working with, the customer can upload all this data, and we have automated reports. So if it's a building with 30 floors with 4 plots in every floor, at this point it's 120 plots that can be generated automatically in an Excel format, or we can just run a PowerPoint plot report for you.
All right, thank you. That's about all the time we have for today's webinar. Again, today's topic was end-to-end indoor DAS small cell measurements and analytics, streamlining small cell measurements, presented by Anite. Again, our presenter today was Deepak Sivakumar, Manager Sales Engineering at Anite. And helping on the Q&A today again was Alex Chua, Director, Product Manager, and Business Development at Anite Network Testing. Thank you, Deepak and Alex.
Thank you.
Thank you, guys.